So welcome to this lesson on chemistry. It's our second chemistry lesson, so I'm really glad you tuned back in. I did wonder if I put you off with the last. So in this particular lesson, we're going to look at the chemistry of fatty acids. And if we just have a little revision about what we discussed in the last session, we talked about the importance of atoms bonding to other atoms in order to form stable molecules and how they have so many hands that they need to have held. And the other thing we discussed was how carbon is so amazingly unique and how you can build lots of chains or even circles of carbon. And that's why life on Earth is carbon-based. So this is a classic molecule that you'll find in our human bodies and in the nutrition that we eat. It is a fatty acid, and it is a common building block for all fats and oils. And as you can see, it satisfies all our rules of chemistry. All of the hydrogens are holding on with one hand. The carbons are all holding on with four hands. And even this one down here, this little carbon has two hands holding on to the oxygen because oxygen needs two hands held. And then this oxygen here is holding on with one hand and onto a hydrogen with the other hand. And this carbon has four hands being held. And this is what we call a fatty acid because it has a long chain of carbons. And that is that is oil loving, and it will dissolve in fats or oils, but it doesn't like water, so it is a fatty chain. And at the end we have this unusual looking group here, which is an acid group, so we get the name fatty acid. And as I say, that is a common building block for all fats and oils. Now this particular fatty acid is one that you find often in coconut or palm oil because it has 14 carbons in its chain, and that makes it a medium chain fatty acid. You also get short chain fatty acids like you get in butter, little tiny ones, and you get long chain fatty acids like you would get in lamb fat or beef fat, where it can contain up to 18 different carbons. And that's the only difference. It's the only difference between the fatty acids you find in butter and the fatty acids you might find in your pork crackling is simply the number of carbons in that chain. The other difference that you can find between fatty acids is whether the carbons have single bonds between each other or double bonds. So in this particular case, this is what we call a saturated fat because it only has single bonds between each of the carbons. So it is fully saturated, and if I blew more hydrogens at it, they would have nowhere to hold on. But if I replaced this bond with a double bond, for a start, it no longer satisfies our rules of chemistry because now these little carbons have 5 hands holding on, and that can't happen. So we have to get rid of 2 of our hydrogens. And this is a double bond. And you get double bonds in polyunsaturated and monounsaturated fats, but of course you don't get them in saturated fats. And what happens with them is these are a little bit of a weak point in some ways. They make the molecule just a tiny bit less stable because if it was given a choice, this molecule would prefer to break that bond and pick up 2 more hydrogens. So now it is a saturated molecule because if I blow any more hydrogens at it, there's nowhere for it to join on. But when it was a double bond, it was considered unsaturated because it potentially could take up more hydrogens. So that is the difference. So the chemistry of the different fats, as a summary, your saturated fats all have single bonds. The only difference between them is how long or short that chain is, and that makes a difference between butter and lamb fat. And then we have our mono and polyunsaturated fats where you get double bonds. Mono meaning one unsaturated bond, so there's only one double bond, and poly means many. So whenever you see a polyunsaturated fat, it will have multiple double bonds, 2 or more. So that's our basic chemistry lesson for fatty acids. In the next lesson, we're going to look at how this changes the behavior of the different fats.